Welcome to another tutorial on Matlab. In this particular series, we are looking into the concept of plant modeling and how it is being used in Matlab and Simulink. In this particular tutorial, we will look into the RLC circuit modeling using Matlab scripting, and the previous video is showing the concept related to the same circuit model development. In case you are interested, please have a look into this video. So as we already discussed, we have a circuit which has a voltage applied, which is a sinusoidal voltage, and there is a resistor for that particular circuit, and there is a capacitor that is in series in the circuit plus the inductor. And the circuit current is I, which is flowing throughout the all components. So to simulate this, first of all, we need to define the time related parameter and the circuit related parameter. So at the beginning, we are defining the initial time, which is time t equal to 0. Then we are defining the delta time. So whatever the sample time that we have. So suppose we are starting with 0, then we will be sampling at the first dt, so that is 0.01, and this way we will be continuing till the end of the simulation, which is the end of end time, which is 10 seconds, which is represented here. So this part we have defined the time. Now we need to know how many elements are there in this particular entire gap. So here we are defining like how many elements are there. Then we are defining like the circuit parameters. So the circuit has three parameters, which is resistor, capacitor, inductor. So resistance is represented here, which is 10 ohms. Inductor represented here, it is 15 millihenry, and this is in farad. So the capacitor is in farad. Once you define all the circuit parameters over here, then we will be creating the state space model. So state space model is the state matrix. So here we have the state matrix, which is represented here. So this is the state matrix. A, state transition matrix. B is the input matrix, which is represented over here. This is A and this is B. So, and CC is the output matrix, which is related to the state. And X is the initial condition. So basically we are telling that there is no voltage in the capacitor or no current in the inductor. So these two quantities are zero at the beginning. That is what we are representing here. So basically we did the setup for the simulation. Now we will be running the simulation over the iteration. So we are ready to do the simulation now. So this is the for loop for the simulation, and here we are changing the input based on the time. So whatever is the time, based on that we are applying this sinusoidal input, and based on this input we are defining how much state is being changed. So this is the change in the state, which is defined by this equation. So that is being defined, and once the change in state is calculated, we need to update the state using the dt time. So this is the dt time, and this is the change. So basically we are integrating the same, and then we are representing the output, which is present here with the help of the C matrix, C into the state vector. So this is the part where it is present. So after calculating all this, we need to store it in some memory location so that we can further on use for it to plot. So we can plot it later on and see how the results look like. After all things done, we need to update the time, and this will be repeated throughout the for loop, and we can get the result. So once we did the simulation and we have all the results stored in these two variables, for this is for the output and this is for the state variables, we can then plot it in two different figures. So first is the state variables, which is the x vector x1, and that we are plotting here. So the first component in x1 is the time, so that we are getting here, which is this one. And then the other three components, starting from 2 to 3, starting from 2 3, we are getting these two. So this is this is the current, and this is the voltage. This is the voltage because voltage is a bigger quantity over here, and this is the current. So that is how it is varying with the voltage that is being applied. And this is the graph for the second plot, which is related to the output. So you can see the output variable over here. So basically, we did the analysis for creation of, or for the measurement of capacitance voltage. And through this capacitance voltage, we are measuring the capacitor outcome voltage. So that is why we have kept the output as VC, which is the capacitance voltage. And this is the plot regarding the same. So this is how you can implement a state space model of a RLC circuit, and you can do the simulation over a amount of time, and you can see the result, how the outcome looks like. You can also change the parameters like the R, L, and C, so resistance, capacitance, and inductance for that particular circuit, and you can do the simulation multiple times to see how the components behaves and influence the voltage and current in the circuit. So this helps in doing a analysis of the particular system that is under consideration. We will be able to conclude like what are the things that is happening in the inside the circuit when we change different parameters of the circuit. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please share it in the comment box so that it will help us to improve your experience of learning MATLAB in this channel. Have a great day and happy learning MATLAB. Thank you.